Hello students, I am Dr. D.D.Kumbhar, Department of Chemistry, Fergusson College, Pune. Today we are going to see the remaining part of this chapter, that is green chemistry and nanochemistry. The remaining principles of green chemistry, ozone depletion, greenhouse effect, the role of green chemistry. Let us move to the PowerPoint presentation. We were discussing about the principle number 10, that is design for the degradation. And after that, we are going to see the illustration part. So we were discussing about what is the resin code. Okay. Now resin codes originated from the Society of the Plastic Industry back in 1988. However, they were only administered in 2008 through the ASTM International Resin Identification Coding System (RIC). From these resin codes have been placed on almost every piece of plastic, which will continue for the foreseeable future. Foreseeable means predicted. So what is the purpose? What is the purpose of this resin code? A plastic resin code or resin identification code shows the consumer which type of plastic resin was used to make the chosen product. That be a plastic bottle, container or jug. The resin is usually defined between 1 to 7 and the relevant number will appear in the center of the arrows on the label that is placed on the product. Then what do they mean? Within the United Kingdom, that is UK, codes 1 and 2 can usually be recycled. However, resin code number 3 is not typically collected from households and is in decline with the introduction of the plastic bag tax resin. Code number 4 now means that plastic bags can be given back to supermarket for reuse. Finally, resin code number 5 and 6 are usually now recycled, whereas resin 7 is usually not. Okay. Now we will see here resin code number 1, that is PETE. PETE means that is number 1, PETE or PET means polyethylene terephthalate, used in microwavable food trays, salad, dressing, soft drink, water and beer bottles. Status. What is meaning of status? Status means importance given to someone. That is meaning by that status. Hard to clean, absorbs bacteria and flavors, avoid reusing. Is recycled to make carpet, furniture, new containers, polar fleece. Okay. Polar fleece means is a soft napped insulating fabric made from polyester. Then we will see the household plastic number 2. Okay. HDPE. HDPE means that is the high density polyethylene used in household cleaner and shampoo bottles. Status. Transmits no known chemicals into food. Is recycled to make detergent, bottles, fencing, floor tiles, paints. Okay. Resin code number 3. V. Capital V. Number 3. V or PVC. Meaning that is the V means that is vinyl. PVC means that is polyvinyl chloride. Used in cooking oil bottles, clear food packaging, mouthwash bottles. Status is believed to contain phthalates that interfere with hormonal development. Please avoid it. Is recycled to make cables, mud flaps, paneling, roadway gutters, etc. Resin code number 4, LDPE. LDPE, low density polyethylene, used in bread and shopping bags, carpet, clothing, furniture. What is status? Transmits no known chemicals into food. Is recycled to make envelopes, floor tiles, lumber, trash can liners. So what do you mean by lumber? Lumber means consists of large pieces of wood. That is the lumber. Trash can liner means that is the dustbin. Then resin code number 5, PP. Number 5, PP means polypropylene, used in ketchup bottles, medicine and syrup bottles. Drinking straws. Status: transmits no known chemicals into food. Is recycled to make battery cables, brooms, ice scrapers, rakes. Okay, these are used. Then resin number 6, PS. Number 6, PS means that is polystyrene, used in disposal cups and plates, egg cartons, then takeout containers. Status: is believed to leach styrene, a possible human carcinogen, into food. Avoid it. Is recycled to make foam packaging, insulation, light switch plates and rulers. Then last one, resin code number 7, other. Number 7, other means that is miscellaneous. Used in 3 and 5 gallon water jugs, nylon, some food containers. Status: contains bisphenol A, which has been linked to heart diseases and obesity. Avoid it. Is recycled to make custom-made products. Okay, so these are the household plastic material. Okay, then next we'll see the principle number 11th, that is real-time analysis, pollution prevention. Analytical methods need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. Then illustration: analytical methodologies should be developed or modified so that continuous monitoring of the manufacturing and processing units is possible. This is very much important for the chemical industries and nuclear reactors. Then next and the last principle, that is the principle number 12, safer chemistry for accident prevention. We need to develop chemical process that are safer and minimize the risk of accidents. Illustration: the substance to be used in a chemical reaction should be selected in such a way that they can minimize the occurrence of chemical accidents, explosions, fire and emission. For example, if the chemical process works with gaseous substances, then the possibility of accidents, including explosion, is relatively higher compared to the system working with non-volatile liquid and solid substances. Then, next important point, that is the ozone depletion. Ozone depletion is a major environmental problem because it increases the amount of ultraviolet radiation, that is UV radiation, that reaches Earth's surface, which increase the rate of skin cancer, eye cataracts, and genetic and immune system damages. So after that, I'm going to show the video regarding that is ozone depletion. So after observing this video, you will come to know that how the ozone depletion takes place.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
I think you have understood the depletion of ozone. Okay. So after that, next point, that is the greenhouse effect. It is also very important. The greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space and the rest is absorbed and re-radiated by greenhouse gases. The absorbed energy warms the atmosphere and the surface of the Earth. So I will show the video. After that, you will come to know that what is by greenhouse effect.
Global warming and greenhouse effect. Earth, the third planet from the Sun. The only planet having a vast diversity of life forms. While other planets of our solar system are either scorching hot or bitterly cold, Earth has a relatively stable temperatures. What is that which is making Earth different? What exactly is making Earth such a favorable place to live on? It is the Earth's atmosphere, which is a thin blanket of air surrounding the Earth from all sides. This air is a mixture of many different gases. Just like an umbrella which protects us from sun and rain, this thin layer of air protects Earth from the harmful radiations from the sun. But this stable temperature is rising every passing year. Oceans are getting warmer. Significant shift in the climate is seen. Glaciers are melting. Why is all this happening? What should be done to stop all this? We'll find the answer to all these questions through this session. Earth is constantly bombarded with enormous amount of radiations from the sun, which we receive in the form of light and heat energy. These radiations, in the form of visible, ultraviolet, and infrared, have to first pass the Earth's atmosphere before reaching the surface. The ozone layer, which is present in the Earth's atmosphere, blocks some amount of harmful ultraviolet rays from reaching the surface. Of the remaining rays reaching the surface, part of it is absorbed by the Earth, and some, especially the infrared waves, are reflected back into the space. But some gases in the atmosphere traps this heat radiation and re-emits it to the surface, which leads to heating up of the environment. This exchange of incoming and outgoing radiation that warms the earth is referred as the greenhouse effect. And the gases involved in this are called greenhouse gases, which mainly includes carbon dioxide, methane, water vapor, chlorofluorocarbons, etc. Friends, but are you not wondering why it is called greenhouse effect? Is it something to do with the greenhouse? If you said yes, you're thinking in the right way. A greenhouse is a glass building in which plants that require protection from cold weather are kept. The glass cover helps to trap all the heat energy and keeps the inside environment warm. Now consider our planet Earth. The atmosphere acts as the glass and traps the heat. The greenhouse effect is essential in order to keep our planet warm. In the absence of this effect, the temperature of the Earth's surface would have been -20 to -40 degrees Celsius. But too much of something is bad, right? If the plants in the greenhouse receives excess heat, it would burn. And if we consider planet Earth, over the last 2 centuries, human activities have changed the Earth's atmosphere in a dramatic way. The amount of greenhouse gases have increased and are still increasing. They trap too much heat. And this excess of greenhouse effect results in global warming, which is an increase in the Earth's average temperature. Consequences of global warming are enormous. Its effects are not limited to one country, but it would affect the entire planet. Knowing the fact that global warming exists and human-made carbon dioxide emissions have caused it, many nations of the world have come together to sign an international treaty, the Kyoto Protocol. The major objective of this protocol are commitment to reduce greenhouse gases by about 5% below their 1990 levels. But what can be done by us? How can we contribute in reducing global warming and also its consequences? Well, planting more number of trees, reducing waste generation, reducing the use of products which generate greenhouse gases, using energy-efficient appliances, increasing the fuel efficiency of vehicles, using more renewable energy, or say switch into greener ways which causes less harm to our environment. That's all for today. I hope you found this session very informative and you got a thorough knowledge of what global warming is.
I think that all of you understood the concept of greenhouse effect. Okay. The next point is that the role of green chemistry. The role of green chemistry. The green chemistry approach recognizes that the Earth does have a natural capacity for dealing with much of the waste and pollution that society generates. It is only when that capacity is exceeded that we become unsustainable. To promote innovative chemical technologies that reduce or eliminate the use or generation of hazardous substances in the design, manufacture and use of chemical products. The green chemistry helps to reduce capital expenditure to prevent pollution. Green chemistry incorporates pollution prevention practices in the manufacture of chemicals and promotes pollution prevention and industrial ecology. The chemistry is a new way of looking at chemicals and their manufacturing process to minimize any negative environmental effects. Right now, the green chemistry revolution is beginning, and it is an exciting time with the new challenges for chemists involved with the discovery, manufacture, and use of chemicals. Green chemistry helps to protect the presence of ozone in the stratosphere, essential for the survival of the life on the earth. Green chemistry is useful to control greenhouse effect, that is global warming. So we should think about save environment and save earth. After that, next point we are going to see, that is the introduction to nanochemistry. From cloths, sunglasses you wear, to computer hard drives and even cleaning products, nanotechnology plays a big part in the manufacture of many materials. We have been using lasers in DVD. DVD means digital versatile disc, and CD players. CD means compact disc. CD players for a long time, which contain nano-sized components. Look at figure 16.1, which show comparative scales. This is the figure, that is macro materials to atoms. The figure 16.1, which shows comparative scales from macro materials to atoms. Also observe another figure 16.2, which depicts the materials in nature as well as devices that are man-made. So here you will observe that all this material, that is the macro material. Here also this 16.2 figure, it indicates that scale of nanomaterials. In both figures, some objects like tennis ball, figure number 16.1, then ant, human hair, figure 16.2, we can see with our own eyes. Whereas bacteria, virus, red blood cells, we cannot observe with naked eye. These are known as nanomaterials. μm, that is micrometer, also called micron, that is 0.001 millimeter. What is nanoscience? Nanoscience is the study of phenomenon and manipulation of materials at atomic, molecular, and macromolecular scales, where properties differ significantly from those at a larger scale. How do we define nanotechnology? Nanotechnology is the design, characterization, production, and application of structures, device, and system by controlling shape and size at nanometer scale. Why nano? The nanometer scale, nano is Greek mean dwarf, but in actual case, nano is even smaller than dwarf. Conventionally, the nanometer scale is defined as 1 to 100 nanometer. 1 nanometer is 1 billionth of a meter. That is, 1 nanometer is equal to 10 raised to minus 9 meter. The materials we see around us are bulk material that possesses macroscopic physical properties. Grain of sand, that is micro-sized material, also possesses same bulk properties. But material synthesized at nanoscale, that is 1 nanometer to 100 nanometer, possesses unique optical, structural, thermal, catalytic, magnetic, and electrical properties. These properties change as a function of size and are very different from their bulk materials. So what is nanomaterials? The nanomaterial is a material having structural components with at least one dimension in the nanometer scale, that is 1 to 100 nanometer. Nanomaterials are larger than single atoms but smaller than bacteria and cells. These may be nanoparticles, nanowires, and nanotubes. According to dimensions, nanostructured materials may be large organic molecules, inorganic cluster compounds, and metallic or semiconductor particles. What are 0, 1, and 2-dimensional nanoscale system? Number 1, 0-dimensional nanostructures. For example, nanoparticles. A 0-dimensional structure is one in which all these dimensions are in the nanoscale. Dimensions means a measurable extent of particular kind such as length, breadth, and width. One-dimensional nanostructures. For example, nanowires and nanorods. A one-dimensional nanostructure is one in which two dimensions are in the nanoscale. Number 3, two-dimensional nanostructures. For example, thin films. A two-dimensional nanostructure is one in which one dimension is in the nanoscale. From this chapter today we have seen remaining principles of green chemistry, ozone depletion, greenhouse effect, and the role of green chemistry. Thank you very much.